So, what are we going to do today? A bunch of different things. Oh, actually, today was going to be catch-up day for all kinds of like little things, including I wanted to finish our sketchpad thing because that was like pretty fun. But maybe we'll do that. Not yet, because my computer's off. But someone remind me in like 10 minutes. We're going to like plan sketchpad again. All right. So what are we actually going to do today? I guess we're just going to go over like a lot of homework. Oh yeah, let's do that. Let's go over the parameterization worksheet. How did that go?
You added, then you should multiply them together. Oh yeah, how do you just multiply?
I thought we could just do maybe like 4 and 5, or maybe we don't even have to do 4. I don't know.
Oh, okay.
Would you like to do number 4? Please, like, speak up.
Do you like number 5?
Just number 5?
Well, I mean, 5 is...
Alright, let's do number 5. Number 5 is the following. X equals 2 to the t plus 2 to the negative t. Can you stop talking? Y equals 2 to the t minus 2 to the negative t. Okay, let's be very disciplined about our approach. And let's try to do all the things that you're supposed to do when you do parameterizations, like for example, look at values where t is undefined, etc., etc. Well, I can take 2 to the anything, so there's no problem with t. What can I say about x?
It has to be greater than a certain number. I said 2.
To be greater than a certain number. Okay, and x obviously has to be positive because this is positive and this is positive. Now, if you get really smart about this and you think about the graph of 2 to the t, the graph of 2 to the t looks like this, and the graph of 2 to the negative t looks like this. So it's probably true that the sum of those two graphs, if you do like graphical addition or something, is going to be smallest like at here when t equals 0. Does that seem reasonable?
Yeah.
Yeah, I think that's reasonable. This is pretty much what was going on in Amy's brain. She concluded that x has to be greater than or equal to 2. I think that's right, so I'll put a question mark because I didn't actually prove that. But what's definitely true, it's definitely true that x has to be greater than or equal to 0. Does everybody agree with that?
Yeah.
Right. What else? What can I say about y?
It can be anything, I think.
Yeah, now, I don't know. I'll just put I'm not sure, right? Because now I'm subtracting things that are sometimes large, so perhaps this could be anything. And I guess if I wanted to be kind of serious and perform a graphical addition of these two, then I could graph 2 to the t, and then I could graph negative 2 to the negative t, which looks like this. And based on that graph, it does appear that all real numbers are in the range. So that's my guess at the moment. Okay, now the next very important thing is end behavior. So let's do that. What happens as t goes to infinity? What happens to x and what happens to y? What happens to x? X definitely goes to infinity because that's pretty much like 0 and that's pretty much like infinity. And what happens to y?
Infinity.
Also infinity, because 2 to the negative infinity is like pretty much negligible, but that's huge. All right, 1 down, 1 to go. How about as t goes to negative infinity? Well, now that's 2 to the negative infinity, which is pretty much 0, plus 2 to the negative infinity, so that's going to infinity, right?
Yeah.
It's pretty much just me and Amy here. The rest of you are just dead weight. How about y? Well, now that's 2 to the negative infinity, that's basically 0 minus 2 to the negative, that's minus huge, so that's going to be negative infinity. Amy, do you agree? Good. All right, that's what I got so far. What's up? Did I mess up?
Well, can you conclude that y is all real numbers based on the end behavior because it has to be continuous? Like,
Oh, yeah, I suppose I probably can. So,
There
yeah.
might be numbers missing between, but...
No, I don't think so, because he says this is like a continuous function, because, yeah, of course it is, right? So, all right, sure. So y is, kind of like all real numbers. The range of y. is all real numbers. But even if you didn't get that exactly, like it's kind of, you can still sort of do the problem. Okay, that was about all the information I can get from just kind of thinking about this curve. Now I have to do some algebra. And how do I do it? You don't even like have the worksheet out. It's been like 5 minutes, man. You're not looking for it. You're eating your sandwich.
I was looking for it.
All right. How can we? I like to scream at one student per video, just to keep it real.
Oh, God.
Okay. I didn't even hear what you said. How can we eliminate the parameter? Yeah, there's a cool way, Ishan. What's the cool way?
Oh, no, I don't know this cool way. I added x and y and then like x plus y equals 2 times 2 to the t and
Yes.
x minus y equals 2.
He added the two equations, which is like begging, these two equations are begging to be added. If you add them, you get x plus y equals 2 times 2 to the t. Do you agree?
Yeah.
Raise your hand if you got this problem, first of all. Who am I talking to? Oh, like almost everybody. Raise your hand if you didn't get the problem. So it's only like 3 of you, which is why you're not seeming that impressed by this thing that I'm doing. Okay, then what about if you subtract the two equations, which is another extremely tempting thing to do? Then you get 2 times 2 to the negative t. Oh, brilliant. Now what? Add these two, no, multiply these, now you do multiplication of these two equations. And then you get, well, you get x squared minus y squared equals
4 times y.
4. Right? Because 2 to the t times 2 to the negative t is just like 2 to the 0. Ta-da, it's hyperbola. Jennifer Chen, get it?
Yeah.
So x squared over 4 minus y squared over 4 equals 1. It is the so-called square hyperbola, in which a equals b. And now I can prepare to graph this by, it's going to be a horizontal hyperbola. So I put like my vertices, you know, like where they go, make my happy box. Make my asymptotes. Okay, but now looking back on my end behavior work and also my original work, I see that it's only going to be the right branch of this hyperbola because x has to be positive. In fact, greater than 2. So now I just look at what's going on here. What's going on? Well, when t is negative infinity, I begin at infinity comma negative infinity. So here's my hyperbola, that branch, and here I am at t equals negative infinity. And we go, and then I'm here at like t equals, that's probably 0, right? to 0, because 2, yup. And then t equals infinity. Yes?
Yeah, so I did just that, but something happened if I graph x and y and put a particular point of x versus t and y versus t, if I put a particular point in the hyperbola, it didn't match up. So.
What?
So like if you take the
Like
point.
t be like 1, you mean?
0, 1 on the x versus t and y versus t graph side, didn't see how it matched up.
Okay, we can plug in a number, like how about when t equals 1, what do you get? If t equals 1, you get 2 plus a half, right? So you get like 2 1/2. So, and then when you plug it into the other one, you get 2 minus a half. So you get like 5 halves comma 3 halves. I don't know, that looks reasonable to me.
That sounds right.
So what was the problem? I guess I don't understand
I
still.
don't know. Maybe I just plugged in with my harsh.
Okay, good. Alright, can I have this worksheet? You don't have a question on the last one, you just didn't do it. Yeah, so give me a worksheet. Can I have everyone's worksheet? Ishan's gonna collect them and put them right here. Okay, let's do something else. What else should we do? There was also a homework assignment that was due yesterday. Say yes. Say yes that there was a homework assignment due yesterday. Yeah, there was. Thank you. And let's go over that. It was a bunch of different problems from a couple different sections from Forster. You might need to adjust, or you might need to like slightly turn the camera now. Yo. It was due yesterday. That's your job to figure that out. I want to say it was like page, there was one, yeah, there was like one question on page 362. And I think, right? And it was, I think I just had you do like number 6, which just takes a couple seconds. Number 6 was about, need to get it together, man. Number 6 was about degenerate conics. And so they asked you, they gave you a bunch of conics which were degenerates and asked you like questions about them. Such as x squared plus y squared equals 0, which superficially looks like a circle, right, Pratik?
Yeah.
It looks like a circle of radius 0, centered at the origin. And in fact, what are the set of all points satisfying the equation x squared plus y squared equals 0? It is simply 0, 0. Yeah, just algebraically speaking, if you add two positive things and you get 0, they must both be 0. And so, indeed, the solution, the set of all points satisfying that equation is just that. Okay, how about if the next one was x squared minus y squared equals 0, which looks superficially like a hyperbola. Did you turn the camera a little bit? Yeah. And yet somehow different. What are the set of all points satisfying this equation? Yeah, this is going to be true whenever x squared equals y squared, which will be true whenever y equals x or when y equals negative x. And so indeed, it is a degenerate hyperbola, and there it is. Okay, cool. More. How about C? Y squared equals 0. This kind of maybe-ish looks a little bit like a... Who needs the yearbook?
3 people. Lyndon Yuan, Alex Miao, and Alex Ma.
Can you guys just go grab your yearbooks from her? Okay. So, and yet, it's like a degenerate parabola. What are the set of all points satisfying this? Yeah, just like the line y equals 0, right? And as we kind of discussed, a degenerate parabola is just like a line. Okay, and then how about the last one? It's kind of interesting. X squared plus y squared equals negative 1. What are the solutions to this equation? Yeah, just like no. So that's actually kind of deep, right? What that tells me, Ishan, is that not every second degree equation in 2 variables is necessarily a conic. Every conic is some kind of second degree equation in 2 variables, but there are second degree equations in 2 variables which do not have solutions, and thus no conic is formed. David Miller, question?
If you extend this into complex numbers.
If you extend this into complex numbers, then all bets are off. All right, good. Then there were a couple other questions. There were a couple other problems. Did we also? This was also the homework where we drew all the pretty shapes, right?
Yeah.
Okay. So, and was that it? Was that all there was from the homework? Jennifer Chen, was that all there was? Was it 3 sections? Oh no, yeah, it was a couple other sections too. That's right. I remember now. So, what did in the textbook there are these just like gorgeous and beautiful pictures of paraboloids, ellipsoids, and hyperboloids of various sheets. And which problems did it ask you to do? Like 4 of them or so, right?
3, 5, 6, 7.
Ishan, say it again.
1, 3, 5, 6, 7, 9.
1, 3, 5, 6, 7, 9. Okay, let's do that right now. Number 1 said to do the following. To create the paraboloid formed by rotating part of the graphs of y equals x squared from x equals 0 to x equals 3 about the y-axis. So here's 1, 2, 3. The parabola y equals x squared looks like this. And we're taking that part of the parabola only, so it's like a truncated parabola, and we're rotating it about the y-axis. And when you do that, what shape is formed? Answer, a paraboloid, which kind of looks like a bowl. Yeah, or like a gumdrop or like some kind of thing like that. Okay, gorgeous. That's pretty much all you have to do, right? Just draw it.
Yeah.
Just coincidentally, today in calculus, we are finding the volumes of these shapes, but you don't know how to do that. All right, what else? 3. 3 talks about some ellipsoid. It says take the ellipsoid 4x squared plus y squared equals 16. So really that's just like x squared over 4 plus y squared over 16 equals 1. And rotate it about the x-axis. Okay, wow. Let's do this. This is going to be a vertical ellipse. So I draw my beautiful picture. And then I'm going to rotate it about the y-axis.
Wait,
Right? Isn't that what it said?
that's what it says, and that's what it said. Wait, it said that in the answer key, but not in the question.
Oh, sorry. No, because I'm rotating about the wrong axis. I'm rotating about the x-axis. Okay, if I rotate about the x-axis, what kind of shape is formed? Am I reading this correctly? I think I am. Yeah, it definitely makes a difference. It definitely makes a difference. Although, depending on your art skills, I'm not claiming that it's going to be drawn, but it is definitely a different shape. Right? If you take this particular ellipsoid, someone back me up here. This is the correct one, right? And we're rotating about the x-axis. Can you describe in words the shape formed?
It's like a flat
disc.
Yeah.
Flat disc thing. How about like a real world object?
It's like a donut.
It's not
Yeah, donut
without a hole.
Like a
donut, like a jelly donut.
Yeah.
That's what happens when you like spin an egg.
It's what happens when you spin an egg in a certain way. Yeah, it kind of looks a little bit like maybe like a. It's not quite a hockey puck, but it's like maybe a.
English muffin.
Football.
No, it's not like a football.
Oh, yeah, it's not.
It's not like a football. It is like a you know, curling.
Yeah.
It's like a curling, what are they called? Stone. I think they call them stones, right? Curling, looks like a curling stone. It kind of looks maybe a little bit like a cheese wheel. It looks a bit like a Mento also, I think. All right, there's a name for this. It is called I forget.
I think it's oblate.
An oblate spheroid. Oblate spheroid. Whereas, on the other hand, I also asked you, okay, what's one that's not that? 5? No, 5 is a hyperboloid. 6, 7. Oh, that was the last one I had to do. What if instead? Okay, so that was what you were supposed to do in the book. What if instead we rotated it about the y-axis? Then what kind of shape would be formed?
Eclair.
Now it's like an eclair, or like a football, or like, I don't know, like a potato, or something like that, or like a football, depending on the shape of the ellipse, right? So, and that is called a, I've been teaching this class for 8 years, but I already forget how to do this. It's called a, I forget, it has a different name. Oblate spheroid and a prolate spheroid, I think it's called. Prolate spheroid. Okay, cool. Yes?
So, how do you create like a hyperbolic paraboloid like the shape of a Pringles chip? Or something?
That's a different thing. This is a very excellent question. It's not something you get from rotating a conic.
Oh.
It isn't, but it is. I mean, think about it. Does it look like one?
No, true. I mean.
Yeah. Okay. It's a surface. First of all, it's not like a. Well, I mean, these are surfaces too. Anyway, all right. More problems. Let's do 5, 6, and 7. Wait, are they? Which one of them turns out to be two different things?
7 and 5.
5 and 7. Okay, good. Let's do 5 and 7. So 5. Well. 5 is a hyperboloid. They say the hyperboloid formed by rotating the part of 4x squared minus y squared equals 4. So really that's x squared over 1 minus y squared over 4 equals 1. So we take this, let's just graph that right now. That is also, that's going to be horizontal. Zoom, zoom, and boom, boom, boom. So we have our vertices here, and then happy box like this. I think I'm doing this right. And yet, I want the part of it only, I'm doing number 5, from x equals 1 to x equals 2. Okay, so when x equals 2, what do I get? If x is 2, I get, what's y? Something. If x is 2, I get 16. I get, it's like 2 root 3?
Yeah.
It's like 2 root 3. Okay, anyway, I just decided I don't really care. But basically, this is what the book describes. It is the region of this hyperbola from x equals 1 to x equals 2. And now I am going to rotate this about the y-axis. So if I rotate about the y-axis, what shape gets formed?
Single sheet hyperboloid.
Yes, a so-called hyperboloid of one sheet, which is kind of the shape of like, I don't know, what does it remind you of?
Oh, yeah.
Chinese yo-yo?
It's like
Yeah.
inside of a donut. Like, you know.
Donut, like, if you have a
If you were
circle-
trapped inside of a donut and you were running towards the center, that's what you would see. Yes, I agree. It's kind of like, you know those little things where you stick your fingers in and then your fingers get caught? It kind of looks like that maybe a little bit. It also is the shape of, like nuclear power stations are built in the shape of hyperboloids for certain important reasons. For like structural integrity kind of reasons. And surface area, blah, blah, blah. Okay. That's called a hyperboloid of one sheet. On the other hand, number 7 gives you a different parabola, x squared minus 4y squared equals 4. So really that's x squared over 4 minus y squared over 1 equals 1. And it says to go from x equals -5 to x equals 5. So this is going to be horizontal. Happy box 1. So I think the hyperbola looks like this, I hope. And the vertices are going to be at, am I doing this right? I think so. And then we're going out to like 5. So here's like 5. So what I have is basically this. But it says to go from -5 to 5. So at -5, it looks like this. Okay, does everybody basically agree that this is the hyperbola from -5 to 5?
Yeah.
Okay, good. And now it says to rotate about the x-axis. Well, if I rotate about the x-axis, what shape is formed now? Like a whoosh, 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 whoosh. Except they're not cones. They're hyperboloids is what they are. Yeah, and what we get is like, I'm standing in front of the thing. What I get is like these two disconnected surfaces. So there is a name for this. We call this a hyperboloid of one sheet, and this is a hyperboloid of two sheets. Hyperbola of one sheet, hyperboloid of two sheets. And I guess the idea here is if you are any 2 points on this surface you can like draw a curve connecting them, right? But on this, if you have a point over, if your best friend lives on the other half of their hyperboloid of two sheets, you can never hang out. All right, what does this look like kind of to you?
Hourglass.
Like an hourglass, like a very ineffective hourglass.
No way, it's like a donut somehow.
I think it kind of looks like, do you guys ever wear, you know, like earmuffs?
Oh.
Not earmuffs, but like, if you're gonna be doing some like jackhammering, and you're gonna, and those like super noise, not earplugs, like noise canceling head gear. Oftentimes they like swivel on an axis for easy storage. Does anybody know what I'm talking about?
Yeah,
One
like-
person.
yeah.
Yeah, so you put them on, but then when then they go doo-doo, and you kind of like hang them back up. I think it looks kind of like that. All right, good. That was this. And then on the same homework assignment, there were some questions on various like math questions, right? This was on the homework that was due. Thanks, Sal, for that. This was on the homework that was due yesterday. Shall we go over a couple of those? I think we should do like 2. Do you guys know what I'm talking about? It was, can someone tell me what it was actually? It was like page 389, I want to say, or 398?
398, 27, 28, 31, 36, 37, 41, and 42.
Yeah. Can we pick 2 of these that you think are the most challenging and or interesting, and we can do them really quick? Or maybe, did you guys find them all easy? I don't believe that that's true. It's not that easy. Way to act boring on the video, guys. Thanks.
Okay, let's all smile.
No, I don't want you to stop. I want you to freaking give me and pick 2. All right, I'll pick 2.
Choose 34.
41
Oh, 36.
and 36. Okay, good. Let's do it. 36 says, take a conic with, I'm doing 36. Take a conic with the center at 4, 7. One vertex at 21, 7. and eccentricity 15/17. Well, if eccentricity is 15/17, then it must be an ellipse, right? Say right.
Right, yeah.
Okay, then I understand Buddha. He's always like shouting crap out. Kusal, step it up. All right, so we draw the picture. 2, 3, 4. And here's 7. So here's 4, 7. This is the center. And then 21, 7. Okay, picture.
Not to scale.
Not to scale. 21, 7. That is a vertex. Well, then where's the other vertex?
Negative 13, yeah.
Yeah, that's like 17, so it's going to be negative 13, and negative 13, 7 will be the other vertex. And this tells me that this tells me that that A is 17. This problem's actually really just not that hard, huh?
Yeah, but
If A is 17, then C has to be 15, right? Say right.
Right, yeah.
And if C is 15, then I can just compute what B is, which is 8, and therefore it is going to be x minus 4 squared over 289 plus x minus y minus 7 squared over 64 equals 1. Is that what you got?
Yeah.
Yeah, good. Okay, then we do 41. 41 says there's a hyperbola with vertices at 2, 3, and negative 6, 3, and the lattice rectum length was 10 units. So the length of the lattice rectum is 10. You guys stop whispering or freaking talking all class. Wash that off before your parents see. All right, lattice rectum is 10, which means that b squared over a has to be 5, right? But it is also true that 2a has to be 8 because, right? So a is 4. So if a is 4, then b squared is 20, and so b is 2 root 5. Am I going too fast, or is this just right?
That's right.
All right, so we good basically? And then the center of this thing, if this is 2, 3, and this is 3, 4, 5, 6, negative 6, 3, that means that the center has to be at like negative 2, 3, and therefore the equation of the hyperbola is x plus 2, it's also going to be horizontal, minus y minus 3 squared over x will be stretched out by 16, and this has to be 20. Good? Say good. Can I have some homework? This is yesterday's homework only. Put it right here.
Oh my god.
All right. Then there was the homework due today. How did that go?
It went great.
What?
We're supposed to play on schedule.
Yeah, I know. We're going to finish going over the homework, and then we're going to play on skate bed.
What? What? This is a struggle.
Okay. So, how did the
He's
homework
staying on
due
this side.
today go?
There were some problems that didn't really make sense when you look at the answers, like number 7.
Oh yeah, there might have been like a typo in the back of the book. But the important thing is, do you know how to do, let's do one problem from page 389. Which one would you like to do? 15. Yeah, let's do 15, because it's the only one with the focus not at the center. So, is the camera positioned over here? Okay, so this is 15 on page 389. It says the following. It says that there is a focus at 2, negative 3, and the directrix is y equals 0, and eccentricity equals 1/2, which means it is going to be an ellipse. So we draw it. what does it look like? 2, negative 3. And then the directrix is y equals 0. So there is y equals 0. And eccentricity is 1/2. Okay, so I know it's going to be an ellipse. So I'm first going to make just like a kind of a crappy picture of an ellipse with directrix y equals 0 and focus 2, negative 3. And then I will pick an arbitrary point on this ellipse, and I will attempt to like do math. Okay, well, this is the point 2, negative 3. This is the point x comma y. What is true based on the new definition of conic section? What's true is that the distance from an arbitrarily chosen point to the focus, which will be x minus 2 squared plus y plus 3 squared, square root of that, over the distance from that arbitrarily chosen point to the directrix, which would just be y, right?
Yeah, absolutely.
Absolute value y, okay, whatever, who cares? Equals 1/2. And now, at this point, it's just algebra. That was the thinking required, now we just have to do lots of algebra. So, let's do it. I get 4, if I'm smart, I don't expand the x's, but I do expand the y's. Is it okay if I'm kind of like doing this? Skipping some steps. So we get 4 x minus 2 squared plus 4y squared plus 24y plus 36 equals y squared. And now, if you're the book, I think they just multiplied everything out and just gave it to you as like a lame thing, right? Yeah, but we should be cool and actually do it. But I think also the book picks problems that don't work out nicely necessarily. But anyway, let's just do it. We get 3y squared plus 24y. I guess this works out okay. It's negative 36 plus and now I need a no, I guess I need to do more math. So this is 4 x minus 2. I know this is like riveting watching me complete the square. So that has to be 16, which means I added 48, so I need to add 48 over here also. Okay, final answer, x minus 2 squared over, that's 12, so that's over 3, plus y plus 4 squared over 4 equals 1. I think I did that right. Is that what you got?
Yeah.
Okay, cool, and I'm good with that. All right, good, Pratik, happy?
Yeah.
All right, Pratik, let's do a problem or two from the other half of the homework. Let's do, like, say, 1. But you guys seem to be very good at this. Did you do your homework? No, Friedlander, you're like pissing me off more and more every day. All right.
I'm sorry, Mr. Reese.
No, you're not sorry. Don't smirk as you say it because it really ruins it.
Why?
Page 398. What were the problems that we had to do on page 398?
3, 5, 9,
Oh yeah, 3, 5, 9, 11. No, there are more.
47.
Oh yeah, and 47. Oh yeah, that's important. Should we do 47 first? Because I think that's what I asked to do. All right, so 47. How did 47 go, by the way? Raise your hand if you feel like you just did exactly what you needed to do and it just worked out perfectly. Raise your hand if you were lost. No one? Do we maybe not even need to go